Okay, great. So basically, I'm going to talk today about big data and basically how big data is let's say, reshaping, impacting communication strategy. Okay. So a first question, of course, is what do I mean by big data, right? What does that mean? What does it refer to? And where does it come from? And while this might seem like a simple question, this is actually a problem that people often have when we talk about big data, right? So what does it really mean? And actually, to illustrate this problem, there is a famous quote from Dan Ariely. So Dan Ariely is a professor from Duke University in the US, and basically is defining big data as such. So I think that big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they are doing it. So besides the joke, of course, what this means is that this really illustrates a deep problem that we have with big data, right? So what this really means, where does this come from? What does it refer to? What are the challenges associated to it? And what is, of course, the value associated to this data, and how can this, let's say, change or impact your strategy, right? For example, communication strategy, right? So first, what do I mean by big data, and what is big data? So big data comes from, let's say, a basic phenomena that we have witnessed over the last decades, right? So basically, we have witnessed an exponential growth of our technological capabilities, right? So take technological capabilities both in terms of storage, so how much data you can actually store, and also in terms of computation, so how many data you can process per second or per minute or whatever, right? So basically today, and I'm sure most of you have noticed this, your computers are millions of times more powerful than before. So for example, in terms of storage, well, today you can buy a hard drive for 500 euros, and this hard drive would allow you to store, for example, the entire, so all music that were ever produced since the beginning of time. Or in terms of computation, well, if you take just two Nintendos that were produced more than 20 years ago, well, the computational power that were associated to these two Nintendos were actually enough or comparable to, let's say, the computational power that allowed the Apollo man to go to the moon, right? So these are just two simple examples to show that really there is an exponential, let's say, a huge increase in terms of our technological capabilities. And of course, this increasing capabilities to both collect and process data led us to what we call a data explosion, right? And here I'm going to give you three very different but simple examples that really illustrate how this, let's say, this improvement in terms of processing and collection of data basically produce this data explosion, right? So the first example is about astronomical data. So at the beginning of 2000, so there was the launch of what people call the Sloan Digital Sky Survey. And the goal of this particular project was simply to collect data about galaxies, stars, etc. by taking pictures with a huge telescope, right? So what they did is to design a huge telescope that over, let's say, a time period of 15 years, so until 2 years ago, basically was able to collect more than 140 terabytes of data and was also able to collect images, about 25% of the sky, basically, okay? And what is interesting here is that basically 2 years ago, they introduced like an improved version, a new version of this telescope, of this project. And basically this new telescope that is much more powerful and that can store many more data, well, this new telescope is capable to collect the same amounts of data that they collected in 15 years, but only in 5 days, right? And not only that, but they can also take pictures of, let's say, 100% of the sky around us, and not only 25%. So this really let's say, illustrate, and you can imagine, let's say, how much data this can represent, right? So instead of 15 years, only 5 days. A second example, very different example, is about genetic data. So maybe some of you are aware of the Human Genome Project. So this project was launched at the beginning of the 90s, and the objective, the goal of this project was simply to fully sequence the human genome, right? While this might seem simple, this is actually extremely hard to do because it's extremely complex, and this really requires very specific algorithms that can actually collect and store a huge amounts of data to be processed, okay? And it took about a bit more than 10 years until 2003 to be able to fully sequence this genome. And of course, thousands of people, hundreds of research labs were involved into this. And this roughly cost about $1 billion to build this, to be able to fully sequence this genome. And today, so a bit less than 15 years later, well, it takes only 1 day to fully sequence, for example, your genome. And it costs not $1 billion anymore, but only $3,000. So this is another example that illustrates, let's say, the incredible improvement in terms of processing and data that you can actually store to analyze. And of course, the last example is maybe the most popular one, is social data. So every time you use your cell phone, every time you send emails, every time you use your credit card, or every time you use your car with the sensor, or every time you send messages, you use social networks, internet, etc. Well, all of these daily activities are, of course, producing digital traces, all right? And today, basically, we estimate that we produce more than 3 exabytes of data daily, all right? So this is a huge number. So this roughly corresponds to 90 years of HD quality videos, for example. And this also corresponds to the total volume of data that were ever produced by humans until 2003, right? And we produce this through our daily activities in only 1 day, okay? And so if we witness an incredible, let's say, increase in terms of the volume of data generated per year. So we estimate here that there is a 40% growth in terms of data generated per year, so by people, by companies, etc. What is also very interesting is that we also see an increase in terms of IT spending, but it's only 5%, which means that we're producing more and more data, but it's also getting cheaper to process this data. So you can think, for example, of all the cloud computation or the distributed applications that you have, for which you have access to now, and it's getting cheaper and cheaper to collect, to process, and to analyze this data. So this is also extremely important to understand. So in the end, what do I mean by big data, right? Well, actually, big data refers to this emergence of this very large data set that are either made of social data, genetic data, astronomical data, or whatever, and that are so complex that basically the tools, the standard tools that you were using traditionally, well, they are now inadequate, right? Both in terms of storage or in terms of processing. It's not possible to use these tools anymore for these kinds of data set, right? And by complexity, by complex data set, I mean, of course, complexity in terms of volume, right? So the volume of data is huge, but also in terms of velocity. So you need to be able to process this data faster and faster. So if you think, for example, in terms of financial predictions, right? Or if you think about self-driving cars, right? So these cars need to make a decision in less than a second, right? Based on the images and the data that they are collecting. And of course, complexity in terms of variety. So we are not talking anymore about just numbers. We are also talking about unstructured data. So for example, textual data, but also audio, video, but also all the data that are coming from the Internet of Things as well. All right. So why is there such an excitement behind this big data, right? Because everybody's talking about big data, right? So the first answer that I could say is because simply data contains value, right? And basically to convince us, if you look at one of the biggest IT companies in the US, for example, Google or Facebook or LinkedIn that was recently acquired by Microsoft, well, what makes this, let's say, this major company powerful is mainly basically the data that they are generating, collecting, and analyzing, right? But of course, having a lot of data is not what matters the most, For example, if I were to, I don't know, to create a new company and I wanted to scan, let's say, the content of all the books that were ever created, right? I could do this. This would correspond to a huge amounts of data, but this does not mean that basically that my company or the analysis that I would do would be able to extract value from this data. So basically, what matters the most is not the data itself, but really our ability to extract and derive knowledge from this data through what we call data mining. All right, and by data mining, what do I mean? I mean simply the design and the building of reliable, relevant, and efficient methods, algorithms that basically can identify and extract certain patterns from this data, or build prediction models, or building predictions, making predictions based on these huge amounts of data. All right, and of course there are numerous examples that I could give where companies have applied these methods to these large amounts of data to extract knowledge to let's say to answer specific business questions, right? So we can take the example, of course, of Alphago from Google, which is basically an artificial intelligence algorithms that basically can play the board game Go, which is one of the most complex and ancient board game that was created, so a few thousand years ago. And basically what Alphago is doing is simply leveraging these huge amounts of data that it was able to collect on expert moves, right? And not only that, but based on this data, he is also able to generate new data, and more specifically new games based on these, let's say, on this data, right? And this new data that he's creating, this is what we call training data. And so basically, with these huge amounts of data, well, he is able to train by itself, simply. And of course, there was a major artificial intelligence breakthrough last year, where Alphago was able for the first time to beat a Go master. Another example, maybe a bit more popular, is of course the Facebook ads on Facebook, right? And what this method, so through data mining, is doing is simply leveraging all these huge amounts of information that they have about people, right? So for example, who is connected to who, to reconstruct the social network of people, but also looking at the likes, the interest, etc., to basically build a large-scale statistical analysis to better target specific segments of people for a marketing campaign. And basically with this, they can achieve a huge conversion rate, right? And the last example is IBM Watson, so developed by IBM, which is also an artificial intelligence method, which that is, let's say, very different from the others, because this is let's say, an artificial intelligence system that rely on semantic analysis, which means basically looking at millions, if not billions, of textual documents to, let's say, better assist certain experts in taking decisions. So, for example, if you look at legal documents, and if you analyze millions, if not billions, of legal documents, well, this can help, for example, lawyers in taking certain decisions. Or what IBM Watson is also doing is also analyzing, extracting specific patterns and making predictions based on medical documents to also assist doctors. Okay. So of course these are some interesting example, right? So popular example. But what about communication, right? Why would this be interesting for communication strategies? And what let's say are the potential applications that are currently being developed in this area? So what is important to notice here, and I think William already mentioned this point, is that today we witness this emergence of a massive, decentralized, democratic information sources. So what do I mean by this? Is that, well, before basically we had like a limited amount of news sources. So you had official news sources plus some digital ones, right? But now, and it's been more than a decade now we can, basically everyone can become a source of information, right? So through, of course, social media, but also blogs, forums, or comments that you can put on newspapers and these kind of things, right? And basically this really enables, let's say, also the application of interesting data mining algorithms on these huge amounts of new information sources, right? Enabling, as I wrote here, new communication strategies. So here I'm going, let's say, to present 4 different applications that I believe are relevant for communication. So the first, let's say, application where big data is playing an important role is, of course, first to identify, engage with key opinion leaders. So if basically with this new, let's say, with these huge amounts of information that you can collect, for example, on companies or on people, well, one of the things that you can do is to draw a connection between these companies or between these people, right? Either from, I don't know, so friendship links, professional links, or shared interest, or these kind of things, right? And if you're able to, let's say, to build this network for a particular group of people, well, you can let's say, apply some very interesting data mining tools. And these data mining tools, when applied to networks, are what we call network science tools. And basically what is quite interesting is that this is a kind of, let's say, of a new field of research, is that we can now run some very interesting, let's say, data mining algorithms on huge networks. And one of the things that we can do is, for example, to identify a key person in that network. And by key person, I mean people that would maximize, for example, how the information would propagate, right? So if you were to simulate in that network how information would flow, or if you were to give a signal to that person, well, while contacting this person would maximize the propagation of this communication to his neighbors, etc., right? And by applying this, let's say, these algorithms, well, you can basically better target or better, let's say, design your communication strategy. So you can really engage with key people. And to give you, let's say, maybe a more concrete example about this, well, there has been a research based on social network data, and what they did is that during the election, I think it was in the US election, what they did is to identify certain person, and they just send them very small signals about the election, right? And what basically they discovered is that by simply giving very simple signals, right, small ones, but to key people, they were able not only to influence these people in the way they were voting, but also influencing, let's say, how other people around them were voting, right? And there are, let's say, numerous research about this. Another important, of course, area is how you can now individualize or tailor your communication toward a certain segment of population, right? So now there is, of course, access to social data, etc., about people, but there is also, you can also have access to open data, like social demographic data, and basically you can gather much more information about people, about groups, and understand basically how they are behaving, and also their different characteristics. And based on this, you can better, let's say, understand how these people would react towards a certain topic, right? And this is also extremely important. A third topic, quite different, is, of course, the detection and also the anticipation of major trends from these, for example, from these decentralized news sources. So basically, what some companies are doing is that by analyzing, let's say, by monitoring what's happening, let's say, in all these different news sources, so from social media, etc., well, they can detect abnormal behaviors, right? And by analyzing certain patterns in this abnormal behavior, they can detect extremely, let's say, interesting phenomena. For example, we can think about natural disaster, so they can predict very quickly if there is, for example, a flooding or an earthquake somewhere. But there is also many research that has been done on, for example, detecting what would be the outcome of an election, right? So you can actually monitor what people are saying and abnormal trends about what people are saying, etc., toward a certain party or a certain people, and you can actually predict what would be the outcome of an election. And there is a famous study about this with German elections 3 years ago, where they were able to predict, so 2 weeks before the end, let's say, the change that happened, so between the two leaders. And And of course, there is also there is of course the possibility to also during elections, for example, to identify, for example, political tensions that could arise, and or for example when a riot would happen. And there is also a famous let's say method that has been developed, and that basically allows people to detect riots even before the police does. And the last example, and I think William mentioned this as well, is of course basically given these huge amounts of data, right? So you have official news sources, and then you have these huge amounts of data coming from basically from all the people, from all the companies, etc. Well, what is interesting is that you can really compare the different, let's say, information that you would get on a similar topic. And this basically allows you to filter out and to filter out this information to basically decide what to ignore or what to address. And there has been as well, let's say, many studies on this where they basically were able to estimate, to evaluate the bias that were present in certain media. And the most, or another way to say this is how to spot, for example, fake news or bubbles of fake news that are, let's say, impacting a certain segment of the population. Okay? So these are, let's say, some areas, applications where big data or the application of data mining methods on these huge amounts of data can change, can have an impact on the way basically you can communicate to people. And of course, well, big data is of course associated to big challenges as well. And here I'm going to talk about 3 of them, but there are many more. And one of the most important one is of course a problem of veracity. So today, basically, we witness a paradox between the amounts of data that is available to us and the veracity, so the trust, the reliability that is associated to it, right? So basically today, we have, let's say, there are more and more data that you can gather, for example, on a certain topic, but it's getting harder and harder to filter out what is true and what is false. So basically, it's extremely difficult when you design, for example, a prediction model or another types of method to really be able to trust the data that you have, right? So you have to be very careful in the way you design your methods. Another problem, of course, and it's one of the major ones, is analytical problems, right? So, for example, let's say that you are a banking organization, right? And you can take decisions whether this particular company or this particular person should receive money or not, right? And to make this decision, well, basically, there are very good prediction models that can do this now, right? But the question is, how far should this model go, right? How far in terms of what kinds of data can this model use? For example, it could use, I don't know, how much money you are making or your professional track record. So this would be more or less fine. But for example, we could also think where you live, the region you come from, the color of your skin, and these kind of things, right? And there, of course, this can be a huge problem, right? Because if any of these sensitive variables have an important predictive power, I think there is, let's say, it can be extremely difficult and sensitive to use this information. And as William mentioned today, there is the GDPR that are coming out in Europe next year, and that basically will set a legal framework around what we can and cannot do with the data, and how people and companies can trace let's say, the data that we are using that some companies are using, for example, for these analysis. And the last, of course, challenge is of course to find people that actually have the knowledge and that can understand these challenges to, let's say, to better design these methods, right? And I can see that every month, right? So when we try to hire someone, it's extremely difficult to find a good profile, right? So somebody that has the good knowledge, the good technical knowledge, but also the good creativity associated to it, right? To solve the many challenges that are offered by these huge amounts of data and the new methods that are coming on top of this. But of course, hopefully there is now, let's say, an educational shift. So basically there are more and more universities in Europe and all over the world that are now first offering what we call, for example, data science course or big data course, so that students can be better, let's say, formed in these different technologies. But also there is a shift in the way they are, let's say, offering these courses. So now there is, for example, the MOOC, so this massive online course that anybody can follow from anywhere, which is, of course, a real benefit for these applications. And thank you very much.